Hello everyone, welcome to this tutorial. My name is Emerson Ahari. I'm a Google Earth Engine expert. In this tutorial, I'm going to show you how to do temporal disaggregation in the Google Earth Engine platform, specifically for NDVI data. This is a very useful tutorial for those of you who want to increase the frequency of desired data in the Earth Engine platform. So, in the first step, you must call the kind of satellite data you want to work. For example, I'm going to work with NDVI data. That's why I'm going to call the MODIS NDVI product. As you can see, the MODIS NDVI product listed here, some of them 16 days and some of them might be in with 8 days. So I'm gonna select one 16 days product here and import it into the code. You can use this tutorial for all satellite products available in multi-temporal format. Doesn't matter it is actually NDVI, evapotranspiration, land surface temperature. You can call actually multi-temporal data such as 16 days, 8 days, monthly, or even yearly, and then use this tutorial to increase the temporal frequency. For example, I have it here 16 days product and I want to actually increase temporal frequency or disaggregate it to daily format. So the benefit of multi-temporal data such as 16 days, as I mentioned earlier, is that allows you to have a clot-free images with a good accuracy, and then when you increase the actually or disaggregate it into daily frequency, in that case you will have daily data clot-free NDVI or other products you want to work. So in the first step, define a variable. For example, here my variable is MODIS equals to image collection. So assign the image collection to the MODIS variable and select the target band. The target band here is NDVI. So it's very important to don't use any filter date or filter bound in this step, because first we must make a framework for daily data. We must have a list of daily data, a list of daily formats and dates, and then we can actually disaggregate MODIS into daily format already created. So now define the period of time you want to produce the daily data for. For example, I'm gonna produce daily NDVI for 2023. That's why time start equals to 2023 and time end equals to Earth Engine date converts a string into date format 2024, just like that. Next, calculate the difference, the number of the days we have between time start and time end. Time difference equals to from time end dot difference. Calculate the differences between time end and time start based on a unit. The unit here is the days. I'm going to calculate the number of the days we have between time start and time end. So number of days, let's get a print to see how many days do we have here. 365 as expected here. So the next step, we need a list with 365 record. Earth engine.list.sequence. As you can see here, we can have a list of sequence starting from 0 and ends to time difference. But let's turn it into Earth engine number, or turn it into the number format, time difference I mean. So as the list is starting from 0, actually it's important to subtract the time difference from 1. That's subtract by 1. So the step is also important. We want to have a list with daily frequency. That's why the step should be 1 equal to 1. So In the next step, we want to add the date, or let's get a print first and then I will back. Here we have a list starting from 0 to 364, as I mentioned earlier, with 1 day interval. Now I'm gonna have the dates instead of actually the number. I'm gonna replace the numbers by the dates. Let's make a loop structure, and each number consider it as an interval here. So now the function returns from time start dot go advance based on interval as a delta, and the unit should be days, just like that, days. And get rid of the time zone and run a code again. You will see a new list with 365 elements. This time, instead of simple numbers, you will have the dates actually changing with daily frequency. So, the list of dates created for 2023. This is the date framework I pointed out earlier. So, in the next step, we want to actually call uh, images for each date to do calculations to estimate the daily data. We need to use the previous days and also the after days temporal information, or temporal actually date information. So, and then there is the equation allow us actually to simulate, or actually make a new product for each date based on frequency that we have. For example, now we have 16 days, and we can actually interpolate the data we have between uh, two 16 days data. For example, one data might be here and another one might be here, for example, but the between is empty. And now I want to show you how to interpolate it based on temporal relationship here. It's very easy. Just try to practice the code step by step. So in the next step, a new variable as daily created equals to get image, bring all the list or list information into an image collection format, because at the end we want to have an image collection. So make a loop structure with a function. Each list, actually each record in the list contained a date. So here we have date list. Each input here, consider it as date list. So now a new variable as date created, we must convert the date list into date format. As they are in the list structure, it is important to use EarthEngine.date to make sure that actually each record included date information. So that's the first step. In the next step, we want to call actually consecutive 16 days data. So here for each date, I'm gonna find the image 16 days after and 16 days before. So for example, the before image equals to already modis variable created. Bring the modis variable here and filter it now based on 16 days earlier. So two arguments we have here. The end date could be must be equal to current date we have in the list, and a start date equals to date.advance, but this time we want to go back, now go forward. the delta should be equals to minus 16, because every 16 days we have one NDVI, and for each date I'm gonna call the image available 16 days earlier and 16 days later. So unit equals to date, and get rid of the time zone here. So in the next step, let's sort all the data based on system time start properties. Turn it as false to select, actually turn it to false structure, because in that case the earliest image actually could be considered as a first image. So we can use the same structure for 16 days later. The after image equals to, again, get modist data, filter it based on 16 days later, starting from current date until the next date. Date.advance, this time positive 16 considered. So based on days interval. Again, sorted based on system time start information and with true condition, and select the first one. Now we have selected the image is available 16 days after the current date. So the before and after image selected in this in before or using before and after variables. In the next step, we want to calculate the ratio. The ratio is an equation. So the ratio is a kind of equation equals to, so the current date dot difference, as you can see here, the current date difference until uh, uh, actually the ratio is a coefficient calculating based on number of the days we have from date or current date until before and after date. So that's why we must have the before date information and after date information. These are NDVI images available 16 days earlier or later. But now we must have their system time start too. So the next is before time equals to Earth engine date. Make a date structure first, and then get the before image. From properties in the before image, select the system time start. As it is pointed out in the previous tutorials, when you want to get temporal information or data acquisition, .get must be used, because the system time start here is a property. If you want to get a band, .select can be used. So now this was for before time, and now we want to have after time. Earth engine date, get the after image, and get the same property here. So the before time and after time calculated. Let's go for the ratio, that is a coefficient. Coefficient is better. So first, calculate the differences or the number of the days between current date and before time. So before time based on days divided into, there it is. This is kind of interpolation equation. So but coefficient should be added into equation. So, and here the after time, that's difference with before time, calculated again based on number of days. There it is. Now we have coefficients. So NDVI daily equals to the after, before, and coefficient. Everything is ready. Just we must make a data set from before and after. Before, that's add bands with before and after together, must have them together, and use the expression to write the final equation. The final interpolation equation equals to, so call the previous image plus the differences between after image and previous image, or previous or before, no matter, you can use any name here as unknown variables. After minus before multiply coefficients. There it is. This is an equation we used for actually interpolating NDVI, daily NDVI data that's only available every 16 days. So now there is a problem here. Before, after, and coefficient, all of them are unknown, and we should define a variable instead of each. So first, before equals to before image, before NDVI image, after, because we want to have a new NDVI, after equals to after NDVI image already calculated, and coefficients explaining the time difference. So coefficient equals to coefficient variables. The output name, band name, will be NDVI with daily frequency that will be returned by the function as NDVI daily. The new daily data must have a new system time start for the actually subsequent temporal analysis. System time start equals to dates. The date included the daily information we already created. So let's get a print to see how it is work. First, I'm gonna print the modis data while it is filtered based on system time start and time end, 2023 I mean. So, and then I'm gonna print the daily NDVI data that is already created for 2023. So, let's save your code and run it again. After a few moments, you can see first we had only 23 NDVI data with 16 days interval, but now we have 365 NDVI data with daily frequency and a new system time start and also the new band name. So now we want to check it out, the quality of the output. So let's select a place, or let's select a region of interest in a word, no matter which area you are selecting. Just you need to select a region in your study area. For example, I'm gonna select a part of agricultural area in my own country, Iran. So I prefer to select an agricultural area in the northwest of Iran. You can choose any other areas, depends on your location or study area. So then I'm gonna actually plot NDVI variations with 16 days interval and the daily interval for the selected region. Let's make a new chart. User interface, chart, .image, .series. There it is. Couple of arguments necessary here. The image collection should be, for example, first we want to have for original modis data starting from time start to time end, 2023 I mean. The region of interest already defined by a geometry. In the geometry, I'm gonna aggregate the NDVI values, spatial aggregation by a statistical operator, for example, average here. The scale equals to the spatial resolution, but the spatial resolution for this product was 1000 meter or 1 kilometer. If you go to the bands here, you can see the resolution is 1000 meter. The X property, system time starts, just like that, and run a code. In the right panel, a new chart is generating that shows NDVI variation for this area with 16 days interval. Let's make another chart to show the NDVI variation with daily frequency. Let's try with a new chart structure. User interface, chart, image, .series. So this time the chart is creating based on daily data for the region of interest already named as a geometry. We want to have the average value for the region. The scale set to 1000 meter and X property equals to system time start, the property explaining the temporal variation. Let's run a code, and in the right panel you will have two charts, the first with 16 days interval, the second with daily interval. If you go to the data and click on download CSV, you can download it with the daily frequency. As you can see here, it has the daily frequency and these are the NDVI data. But there is a problem here. The NDVI must be ranged from -1 to +1. But here we have very large values. The large values back to the scale factor or the scale or coefficients. So there is a coefficient for the MODIS NDVI data already pointed out in the data description. So if you want to see the NDVI in the main or original or the real range of value, when you return the NDVI daily, it must be multiplied to the scale factor. Let's run it again. In the right panel, you can see the new NDVI with the correct range of values that is updated earlier. So there it is. Now we have the daily NDVI value with the same trend of variations. So this is a kind of interpolation technique in the Earth engine. So in the next step, I'm gonna actually show the NDVI daily NDVI image. So through the map.add layer. The daily NDVI data is noise free and also without any cloud or noise impact. So map.add layer, for the daily data I'm gonna select only one month, filter dates, for example for June, from June 1st to July 1st 2023, July 1st. Let's visualization parameter empty, and the name should be daily NDVI. Set the shown as false to avoid automatic visualization. So now let's try to select a bigger space and put all NDVI layers into a single stack layer. Sorry, just a moment. Yes. So sorry, something is wrong on my keyboard. So that's two bands, that clip. So clip it based on a geometry. Save your code and run it again. So go to the layers. At the moment, you will have a new NDVI data in the layer setting. Check it on. Something seems wrong. NDVI clip. Oh, yes. And now here we have a problem about geometry of the output. And sometimes this problem actually caused when you are dealing with the Earth Engine platform. Here we can actually reproject our data. For example, there are some reprojection methods. We can use them to reproject data from original coordinate system to, for example, WGS84. Let's try with a reproject. So with the reproject here, just a moment, I'm gonna restart my keyboard because seems something is wrong, and now I'm gonna actually fix the problem to able to handle this tutorial. Sorry, but I need to fix the problem now. Yes, I think the problem is solved, and now I can actually show the arguments by pressing on Control and Space. The CRS, the Target Coordinate System, EPSG 4326. This is the unique code that you can use for WGS84. CRS transform null and scale 1000 meter. Let's run a code again and hope that the problem is solved. Again, I think we have a same problem. Let's try with resample first. That's resample and then reproject. Still the same problem here. Okay, or we can maybe use clip to bones and scale. This is another solution that you can use for such problem. If reprojection not worked, then try to resample your data here. Try to actually clip to bones and scale. Couple of arguments must be considered here. Only geometry, leave the weight and height as null, and also the scale could be 1000 and max dimension null also. Run it again. Yes, the problem is solved. Hopefully we handled the problem with the clip to bone and a scale, as you can see here. And now you can select, for example, the daily NDVI data and increase the contrast width. As you can see, this is the NDVI daily without any noise or cloud impact. That could be very, very beneficial for environmental studies or agricultural studies you want to have. So, and maybe if you try to clip the layer earlier, the problem is solved. Let's see, I'm not sure. So let's clip based on geometry. Oh no, the clip.geometry actually doesn't work for this product, and then you can use clip to bound and scale. Yeah, that might work actually. Or let's try with resampling in this step. I'm actually trying to add different solution here to find a way to solve the problem. So instead of clip here, we can try with resampling first here. Resample with bilinear format and reproject into EPSG 4326, and now let's spatial resolution to 1000. Let's run a code and try to use the simple clip instead of this. Let me to make a copy first, because it may actually don't work here. That clip based on geometry. Let's run a code here. The daily NDVI clipped, separated from the previous one. Yes, now it's worked. Okay, hopefully the problem is solved. The solution was here. After multiplication, I used actually a resampling process to WGS84, and then clip simply works without any problem. So this is the NDVI daily NDVI data, and here you can see the daily NDVI. And if you want to see the date next to the band name, it is also very simple here in the Earth engine. Make a new system index that set system index equals to date with the normal format, including year, month, and day. Save and run it again. Daily NDVI. I hope it's working. Yes, now you can see the daily NDVI data. For example, you can select one date and use the stretch to increase the contrast. There it is. For June 21, June 22, and June 23, for example. There it is. So I hope you like this tutorial, and this could be very helpful, very useful tutorial for you that allows you to increase the temporal frequency, specifically for dynamic phenomena such as the NDVI vegetation cover. That could be very beneficial to monitor vegetation cover or anything else such as evapotranspiration with a higher frequency, with a higher temporal frequency. And now if you want to know how to get export, it is also very simple technique. Just try to use export.image to drive. There it is. Export.image to drive. Couple of arguments important. The image you want to get export. For example, I'm gonna get export from NDVI data for June already clipped based on region of interest. So the description refers to the name of the output here, daily NDVI 2023 June, and scale equals to 1000 meter, and the region of interest equals to geometry, and maximum pixels for each frame equals to 1e13. The target folder to save your data could be test or anything else. You can pick any other name. And the last thing is, I don't remember what was that, the description, scale region. Oh, CRS, coordinate system. CRS equals to EPSG 4326. This is actually a unique code for all around the world. Whenever you want to use WGS84, just try with EPSG 4326. Let's save the code and run it again. Export that image to drive. Something is wrong. Unexpected arguments to drive. Export image. Export image to drive. Why it is unexpected? It is a little bit weird. Unexpected argument. Oh, images. Oh, it was my fault. Actually, it is image. The image we want to get export is daily NDVI data. Let's save the code. Go to the task, click on run. And the process of saving in Google Drive is already started, and once the tabs color turn to the blue, meaning that you can go there and pick it up from your Google Drive and open it up into your desktop software. So I hope you liked this tutorial, and if you had any problem or challenge about this code, feel free to pick up my code. The code link actually available below the video on my YouTube channel. You can reach me out in the YouTube channel and ask me your questions. I will try to answer your questions as soon as possible. Thank you for your attention, and please don't forget to share this tutorial with other interested users in all around the world. Thank you for your attention.